Welcome to Lecture 11, Analytics and its Implications. This is your Professor Atif Reed Muhammad. We will articulate the differences between descriptive, predictive, and prescriptive analytics. We'll also describe the impacts of advances in analytics on data management technologies and practices. We'll analyze and articulate the implications and potential consequences of the use of analytics technologies on societies, organizations, and individuals. Let's look into these terminologies with a use case. In the context of database management systems, analytics play a crucial role in transforming raw data into actionable insights. Analytics involves the systematic analysis of data to uncover patterns, trends, and correlations that can inform decision-making processes. By leveraging advanced analytical tools and techniques, organizations can extract valuable information from their databases, enabling them to make data-driven decisions that enhance operational efficiency and strategic planning. Analytics in DBMS encompasses various methodologies, including descriptive analytics, which provide a summary of historical data to understand past trends, predictive analytics, which uses statistical models to forecast future outcomes, and prescriptive analytics, which suggests actions to optimize performance. These analytical capabilities are essential for businesses and institutions such as universities to gain a competitive edge by identifying opportunities, mitigating risks, and improving overall performance. By integrating analytics with DBMS, organizations can harness the full potential of their data, driving innovations and success in the increasingly data-centric world. Whereas business intelligence, a set of methodologies, processes, architectures, and technologies that transform raw data into meaningful and useful information. So moving from decision support system to analytics, this is a pictorial representation which shows us the movement that started from decision support system to business intelligence, which later evolved to the analytics. Starting in 1960s and in late 80s, it was BI or business intelligence, and the analytics kicked in start of mid 2000. Types of analytics. Let's take one example each of all these: descriptive analytics, predictive analytics, and prescriptive analytics. Descriptive analytics is a fundamental technique used by businesses, including bookstores. Let's take bookstores as an example, to understand their past performance and make informed decisions. For a bookstore, descriptive analytics involves collecting and summarizing historical data such as sales figures, customer demographics, and inventory levels. By analyzing this data, bookstore owners can identify trends and patterns such as which genre are most popular, peak sales periods, and effectiveness of marketing campaigns. This insight allows them to understand what has happened in their business and why, providing a clear picture of their current standing. For instance, a bookstore might use descriptive analytics to discover that mystery novels have been their best-selling category over the past year, with a noticeable spike in sales during holiday seasons. This information can guide the store's purchasing decisions, helping them stock more mystery titles in anticipation of future demand. Additionally, by examining customer data, the bookstore can tailor personalized recommendations and promotions, enhancing the shopping experience and fostering customer loyalty. Through descriptive analytics, bookstores can transform raw data into meaningful insights, enabling them to optimize operations and better serve their customers. Now let's look into predictive analytics. Predictive analytics takes the insights gained from descriptive analytics a step further by using historical data to forecast future trends and behaviors. As we are taking the bookstore as our example, this involves applying statistical algorithms and machine learning techniques to predict outcomes such as future sales, customer preferences, and market trends. By analyzing past sales data, customer purchasing pattern, and external factors like seasonal trends, a bookstore can anticipate which books or genres are likely to be in high demand in the coming months. For example, predictive analytics might reveal that sales of children books tend to surge during the summer holidays, while self-help books see a spike in January. Armed with this information, the bookstore can proactively adjust its inventory to meet anticipated demand, reducing the risk of stockouts and ensuring the popular titles are readily available. Additionally, predictive analytics can help in identifying potential opportunities such as emerging genres or authors who are gaining traction, permitting the bookstores to stay ahead of market trends and capitalize on new opportunities. Whereas prescriptive analytics build upon both descriptive and predictive analytics by not only forecasting what will happen but also suggesting actions to optimize outcomes. It uses advanced algorithms and simulation techniques to recommend the best course of action for achieving specific goals. In the context of the bookstore, prescriptive analytics can provide data-driven suggestions on how to maximize sales, improve customer satisfaction, and optimize inventory management. For instance, prescriptive analytics might suggest that offering a discount on a particular series of books during a specific promotional period will likely increase overall sales by attracting more customers. It could also recommend rearranging the store layout to place high demand items in more accessible locations, thereby enhancing the shopping experience. Furthermore, prescriptive analytics can help in optimizing marketing strategies by identifying the most effective channels and messages for reaching target audiences. By leveraging prescriptive analytics, bookstores can make informed decisions and drive growth and improve operational efficiency, ultimately leading to a more successful and competitive business. Figure 1.1-2 is generation of business intelligence and analytics. So BI&A 1.0 is focused on structured quantitative data largely from relational databases. 2.0 include data from web interaction logs, customer reviews, and social media. And 3.0, technically there is a typo there on the upper side of the slide, include data from mobile devices, location sensors, etc., and Internet of Things. Use of descriptive analytics. Descriptive analytics was original emphasis of business intelligence. Reporting of aggregate quantitative query results, tabular or data visualization displays, dashboard. A few of the key indicators were provided, scorecard like a dashboard, but broader range. OLAP or online analytical processing. Technically, that is also an area that I would suggest you to look into. Let me share with you an example of OLAP. Online analytical processing, also known as OLAP, is a powerful technology used in database management systems to support complex analytical queries and decision-making processes. In the context of a bookstore, OLAP allows for the efficient analysis of large volumes of data from multiple perspectives, enabling users to gain insights that drive strategic decisions by organizing data into multi-dimensional structures such as cubes. OLAP systems enable bookstore managers to perform operations like roll-up, drill down, slice, and dice, providing the comprehensive view of their data. For example, the bookstore might use OLAP to analyze sales data across different dimensions, such as time, location, and product category, With OLAP, managers can quickly aggregate sales data to understand overall performance, roll up and delve deeper into specific details such as sales of a particular genre in a specific store, drill down. They can also isolate and examine the subset of data like comparing sales between different store locations or focus on specific aspects such as analyzing sales trends for a particular author or over time. That is called DICE. By leveraging OLAP, bookstores can perform sophisticated analysis that reveal hidden patterns and trends, enabling them to make data driven decisions. For instance, OLAP might uncover that certain genres perform better in specific regions or that promotional campaigns have varying levels of success depending on the time of year. These insights can inform inventory management, marketing strategies, and operational planning, ultimately enhancing the bookstore's competitiveness and profitability. OLAP's ability to handle complex queries and provide rapid responses make it invaluable tool for businesses seeking to leverage their data for strategic advantages. SQL OLAP querying. SQL is generally not an analytical language, but it can be used for analysis. However, OLAP extensions to SQL make this easier. OLAP queries should support categorization such as group data by dimension characteristics, aggregation such as create averages on per category, ranking such as find customers in some category with highest average monthly sales. Regular SQL query: which customer has bought the most of each product we sell? Show the product ID and description, customer ID and name, and the total quantity sold of the product to that customer. Show the results in sequence by product ID. If we create a whole SQL query on that by selecting p1.product_id, comma product description, comma c1 customer ID, and this you can look into that. This is a very good standard SQL that we can look into in terms of group by and order by aspect. It's also nested because it has more than one SQL queries associated. OLAP SQL query: consider the sales history table, columns territory ID, quarter and sales, and a desire to show the 3-quarter moving average of sales. Select territory ID, comma quarter, comma sales, comma average sales over partition by territory ID, order by quarter row 2 preceding as 3QTR average or third quarter average from sales history. The result is right in front of you. ROLAP, or Relational Online Analytical Processing, leverages relational database management system to perform dynamic analytical calculations on data stored in relational tables. In the context of a bookstore, as we are taking this as our running example, ROLAP allows for flexible and detailed analysis by executing complex SQL queries directly on the database. This approach is particularly useful for handling large data sets and providing real-time data analysis, as it does not require pre-aggregated data. For bookstore, ROLAP can be used to generate detailed reports on sales performance, customer behavior, and inventory levels by querying the underlying relational database. Managers can create custom queries to explore specific aspects of the data, such as identifying top-selling authors or analyzing the impact of promotional campaigns. ROLAP's ability to handle complex queries and large datasets makes it ideal for ad hoc reporting and in-depth analysis, permitting bookstores to gain insights that inform strategic decisions. MOLAP is multi-dimensional online protocol analytical processing. Stores data in multi-dimensional arrays or cubes, providing a structured and efficient way to perform complex calculations and data analysis. In a bookstore setting, MOLAP allows for fast query performance and pre-calculated aggregations, making it well suited for interactive analysis and reporting. With MOLAP, bookstores managers can quickly explore data from various perspectives, such as time, location, and product category, using operations like roll up, drill down, slice, and dice. This multi-dimensional approach enables users to visualize trend and patterns more intuitively, facilitating better decision making. For example, MOLAP can help identify which book genres are most popular in different regions or how sales vary across different time periods. By providing rapid across to aggregated data, MOLAP supports efficient and interactive analysis, helping bookstores optimize their operations and strategies based on data-driven insights. This figure is showing the slicing a data cube. Slicing, dicing, pivoting, and drill down are useful cube operations. So let's see what we have next. The example of drill down, the summary report is brand, soft towel, package size, 2-pack, sale $75. Drill down with color attributes, soft towel 2-pack white, sales are $30, soft towel 2-pack yellow, sales are $25, and that's how it goes. Starting with summary, data users can obtain details for particular cells. This figure shows a schema of what a user interface for a cube might look like. Often the user interface is done in spreadsheet software like Excel. Cubes can display as many dimensions as you want, and the user interface also supports pivoting. So for example, it would be simple to switch the view such that resort name would appear in the column and travel method in the row, or bring countries into columns and number of days into the pages. Although this screen is only 2-dimension, you can include more dimensions by combining more than one dimension in a row or a column by including paging. In figure 11.5, the columns include two dimensions, travel method and number of days. The rows show the 1-dimension resort name, and the pages now show 1-dimension, that is country. Data visualization. Representation of data in graphical and multimedia formats for human analysis. A picture tells 1,000 words. Without showing precise values, graphs and charts can depict relationships in the data, often used in dashboards as shown in the next slide. Charts like these are examples of data visualization. The representation of data is graphical and multimedia formats for human analysis. So the business performance management or BPM systems allow managers to measure, monitor, and manage key activities and processes to achieve organized goals. Dashboards are often used to provide an information system in support of BPM or business performance management. Predictive analytics, as discussed earlier, I'll give you the summary here. Statistical and computational methods that use data regarding past and current events to form models regarding what might happen in the future. Examples are classification trees, linear and logistic regression analysis, machine learning, neural networks, time series analysis, and Bayesian modeling. Data mining tools. Knowledge discovery using a sophisticated blend of techniques from traditional statistics, artificial intelligence, and computer graphics. The goals are explanatory, explain observed events or conditions; confirmatory, confirm hypothesis; exploratory, analyze data for new or unexpected relationships; text mining, discovering the meaningful information algorithmically based on computational analysis on structured textual information. Data mining techniques. Let's look into all of this with our bookstore example in a little bit more depth. Data mining techniques, particularly regression analysis, play a crucial role in helping bookstores uncover meaningful patterns and relationships within their data. Regression analysis is a statistical method used to determine the relationship between a dependent variable and one or more independent variables. In the context of a bookstore, regression can be employed to predict future sales based on the factors such as pricing, promotional activities, seasonality, and customer demographics. For instance, a bookstore might use regression analysis to understand how changes in book prices affect sales volumes. By analyzing historical sales data alongside price points, the bookstore can build a regression model that quantifies the impact of pricing strategies on customer purchasing behavior. Additionally, regression can help identify which marketing campaigns are most effective by correlating promotional efforts with sales outcomes. This allows the bookstore to optimize its pricing and marketing strategies, ensuring that resources are allocated to the most impactful initiatives. By leveraging regression analysis, bookstores can make data driven decisions that enhance their operational efficiency and profitability. Now, let's look into decision tree introduction or induction. Decision tree induction is a powerful data mining technique used to create models that predict one value of a target variable based on several input variables. In the context of bookstore, decision tree induction can help in understanding customer purchasing behavior by analyzing various factors such as age, genre preference, purchase history, and promotional responses. By constructing a decision tree, the bookstore can visually and analytically determine which factors most significantly influence buying decisions. For example, a bookstore might use decision tree induction to segment its customer base and identify key characteristics that differentiate high value customers from others. The decision tree might reveal that customers who frequently purchase science fiction books and respond positively to email promotions are more likely to make repeat purchases. These insights allows the bookstore to tailor its marketing strategies such as offering personalized recommendations or targeted discounts to enhance customer engagement and drive sales. By leveraging decision tree induction, bookstores can uncover actionable insights that inform strategic decisions, ultimately improving customer satisfaction and business performance. Clustering and signal processing are advanced data mining techniques that offer unique insights for bookstores. Clustering involves grouping similar data points together to identify patterns and structures within the data. For a bookstore, clustering can segment customers based on their purchasing behavior, preferences, and demographics, permitting for targeted marketing strategies. For example, clustering might reveal distinct customer groups, such as frequent buyers or fantasy novels or occasional shoppers who prefer nonfiction. On the other hand, signal processing analyzes time series data to detect patterns and trends such as seasonal sales fluctuations or the impact of promotional events. By applying signal processing, bookstores can optimize inventory management and marketing efforts by anticipating demand and adjusting strategies accordingly. Together, these techniques enable bookstores to make data-driven decisions and enhance customer engagement and operational efficiency. Whereas affinity is to discover strong mutual relationships, and sequence association discovers cycles of events and behaviors. Case-based reasoning drives rules from real-world case examples. Rule discovery search for patterns and correlations in large data sets. Fractals compress large databases without losing information. Neural nets develop predictive models based on principles modeled after human brain. Typical data mining applications can continue by looking at profiling population, and developing profiles of high-value customers, credit risk, and credit card frauds. Analysis of business trends, identifying market with above average, below average growth. Target marketing, as discussed earlier, identifying customers or customer segments for promotional activity. Typical data mining applications: usage analysis, identifying usage patterns for products and services. Campaign effectiveness is comparing campaign strategies for effectiveness. Product affinity is identifying products purchased concurrently or identifying the characteristics of shoppers for certain product groups. Customer retention and churn, examining the behavior of customers who left for competitors to prevent remaining customers from leaving. Profitability analysis. Let's look into this in a little bit more depth, as well as customer value analysis and upselling. Profitability analysis is a critical process for bookstores to assess their financial performance by evaluating revenue against costs. This analysis helps identify which products, such as specific book genres or authors, contribute most to the bottom line. By examining factors like sales volume, pricing strategies, and cost of goods sold, bookstores can pinpoint areas of strength and weakness. For example, if mystery novels consistently yield higher profit margins compared to other genres, the bookstore might choose to expand its mystery section or negotiate better terms with suppliers. Conversely, identifying underperforming categories allows for strategic adjustments, such as reducing inventory or implementing targeted promotions to boost sales. Through profitability analysis, bookstores can optimize their product mix and pricing to maximize profits and sustain growth. Customer value analysis focuses on understanding the worth of individual customers or customer segments to the bookstore. This involves assessing metrics such as customer lifetime value, purchase frequency, and average order value. By segmenting customers based on their purchasing behavior and preferences, bookstores can identify high-value customers who contribute significantly to revenue. For instance, the bookstore might discover that customers who frequently buy both fiction and non-fiction titles tend to have higher lifetime values. This insight allows for personalized marketing strategies, such as offering loyalty programs or exclusive discounts to retain and engage these valuable customers. Additionally, understanding the needs and preferences of different customer segments helps in tailoring product offerings and enhancing the overall shopping experience. Upselling is a strategic sales technique aimed at encouraging customers to purchase higher end products or additional items that complement their initial selection. So hopefully this has been helpful. The NIME example of predictive analysis is credit scoring. Take past financial data to produce a credit score, starts the decision trees, neural networks, and support vector machines, algorithms for initial model. Next uses predictive modeling markup language, or PMML. Marketing is churn analysis, predicting which customers will leave using clustering via k-means algorithms. Social media analysis using association rules. Use of prescriptive analytics, its use of optimization and simulation tools for prescribing the best action to take. Example application: making trade decisions in securities and stock market, making pricing decisions for airlines and hotels, making product recommendations, Amazon and Netflix. Often requires predictive analytics and game theory. The languages and tools for analytics are in reality are R, Python, Apache Spark. So you can look into that when you get a chance to conduct a little study by yourself. Data management infrastructure for analytics is scalability, parallelism, low latency data optimization. Scalability is the ability to add capacity, processing resources, storage space, and connectivity based on changes in demand. Parallelism is capability to process, transfer, and access data in multiple chunks at the same time. Low latency is high speed in various processing and data accessed and writing tasks. Data optimization is skills needed to design optimal storage and processing structures. Technologies enabling infrastructure advances in data management. Massively parallel processing. I suggest you to look at massively parallel processing MPP in memory DBMS, in database and analytics and columnar DBMS by yourself by conducting a little research using the Google Scholar or IEEE Explore. This will give you an understanding how to conduct research. Big data analytics impact, as we have looked at big data earlier, the business, e-government and politics, science and technology, smart health and well-being, security and public safety are some of the areas. Personal privacy versus collective benefit, that's a social implication. Ownership and access of the data and the reporting, and the analytics, data algorithm quality and reuse, transparency and validation, demands for workforce capabilities and education. Hopefully this has helped you in learning about analytics and its impacts. See you in the next lecture.